Welcome, Relationship Plots in Python. In this lesson, we will explore how to visualize relationships between data using scatter plots, regression plots, and pair plots. We will use real datasets like airline passengers to understand trends over time. By the end, you will be able to create beautiful visualizations and gain valuable insights from your own data. Running the cell now. What are relationship plots? Relationship plots show how two or more variables relate. They help us spot patterns, trends, and outliers in data. Common types include scatter plots, regression lines, and pair plots. Running the cell now. Let us start by making sure any warnings are hidden. This keeps our notebook tidy. The code tells Python to ignore warnings, so our plots and explanations are not interrupted. Running the cell now. Try running this in any notebook you make. We need to import a few packages to work with data and create plots. The first import is pandas. It makes it easy to load and work with tables of data. We next import matplotlib for basic plotting. It is a popular library for making charts. Seaborn is another library. It builds on matplotlib to give us beautiful, easy plots for data. Running the cell now. If you see an importer, check that packages are installed. Let us try loading a real dataset of airline passengers. We will download the data and make sure it loads correctly. We are loading a file that shows how many people flew each month on an airline from 1949 to 1960. The data is from a direct web link, so there is no need to download separately. After loading, we print the table shape to see how many rows and columns there are. Now we look at the first few rows of the data. This is called previewing the data. Running the cell now. Looking at a preview can help us spot mistakes early. Before exploring relationships, let us see a line plot of the passengers dataset. We make a line plot to show how the number of passengers changes over each month. We set the figure size to make it bigger and easier to see. Dots mark each month, so it is easier to see points. The title, and X and Y labels, tell us what the plot shows. The horizontal axis shows months. The vertical axis shows the number of passengers. We rotate month labels for a better fit. Tight layout keeps the plot neat. Now we show the plot so we can look for trends and patterns. Running the cell now. Can you see any peaks or changes in the trend? Scatter plots, finding patterns. Scatter plots let us look for patterns or relationships between two variables. Each point shows one set of values from our data. Running the cell now. Our dataset has date strings. Let us break month and year into separate columns. First, we make a new column for year by taking the first 4 characters of the month string. We also make a column for month number by taking characters after the dash. Running the cell now. Now we can plot against year or month easily. Let us plot number of passengers against year using a scatter plot. We use a scatter plot to see how passenger numbers change with year. If the dots go up over time, it means there is growth. We make the plot easy to read using labels and a title. This helps us focus on the main question: did travel change over the years? We label the years as the horizontal axis. The number of passengers is on the vertical axis. Now we display the scatter plot. Running the cell now. Do the dots form an upward trend, or are they random? Colors can show more information. Let us color by year to spot patterns. In this scatter plot, each year is a different color. Months are on the horizontal axis, and passenger counts are on the vertical axis. The legend tells us what color each year is. Look for seasonal shapes and whether some months always have more passengers. The color helps us see if patterns repeat every year. We use the Seaborn library here for better colors. We adjust layout and show the final plot. Running the cell now. Can you spot which months are busier across years? Adding regression, line of best fit. Regression allows us to guess a general trend. The line gives a simple idea of, on average, how does one value change with another. Running the cell now. Let us add a regression line to our scatter plot. Seaborn's regplot draws a line of best fit through our data. The blue dots are real points. The red line shows the general upward trend. Regression means finding a mathematical line that follows the pattern. This can help predict future values or spot strong trends. The axis labels and title keep it clear. We now show the combined plot. Running the cell now. Do you think this trend would continue forever? Sometimes, showing just the trend line is simpler. Here, we draw only the regression line without the scatter dots. This gives a clear view of the general increase. This option is useful when data has lots of overlapping points. We keep the same labels and show the result. Running the cell now. You can show or hide dots in regplot with the scatter option. What is a pairplot? A pairplot lets us compare all variable pairs at once. We see different scatter plots and the shape of each column's values. It works best for datasets with several columns. Running the cell now. Let us make a smaller table to use with a pairplot. We make a new dataset with only 3 columns: year, month number, and passengers. This makes it easier to see how Pairplot works. We again display the first few rows for a quick look. Running the cell now. Pairplots need numeric columns to compare. Now let us use Seaborn to make a pairplot. The pairplot makes scatter plots of each pair of variables. It also shows the shape of each column's values as a curve along the diagonal. This helps us look for any relationships without making many separate plots. The title above the chart tells us what we are seeing. Running the cell now. Do you see any columns that look connected? Adding hue can show more groups. Let us color points by decade. We make a new column to show which decade each year is from. Now the pairplot colors the dots by decade. This helps spot whether some patterns appear stronger in certain decades. The title makes it easy to tell what is shown. We display the colored pairplot. Running the cell now. Try thinking of other ways to group your data. What else could you color by? Real-world use, explore weather data. Let us try another time series, daily minimum temperatures. We will find patterns in how temperature changes with time. Running the cell now. Let us load a different dataset about daily minimum temperatures in Australia. We load a CSV file from the web, so the data arrives fresh every time you run this. This table includes a date and the lowest temperature for each day. We check the size and peek at the first few rows. Now you can see the structure of weather data. Running the cell now. If your dataset has missing rows, try reloading or check your internet. Let us quickly visualize temperatures as a line plot. We make a line plot of daily temperature over time. The long time axis will show ups and downs for each year. The orange color is easy to see. Labels help us know what the axes mean. A good title makes the plot clear without guessing. We rotate the dates so they do not overlap. The layout is adjusted so nothing is cut off. The final plot shows weather trends. Running the cell now. Do you notice any repeating yearly patterns? Let us check for warming or cooling patterns throughout the year. We convert date strings to special time objects so we can get the day of year. Each point here is a day's temperature, with a line showing the average yearly cycle. This way, we focus on how seasons change, not which year it is. We use a red regression line to highlight the overall pattern. Axes are labeled to keep it understandable. We run the plot to see the result. Running the cell now. How would this look for other places with different climates? Mini project, exploring your own data. Now, let us try making a relationship plot with your own ideas or numbers. You can use input values below. Running the cell now. Let us build your own scatter plot. Enter lists of numbers and see how they look. First, we ask you to enter numbers for X and Y. After you type them, the code turns those strings into lists of numbers. Each pair of numbers makes one dot in the scatter plot. This is great for experimenting with any two sets of values. The plot will update to show your new points. Try different values to see new patterns. The plot title and axis labels describe your plot. Lastly, we display your plot. Running the cell now. What kind of pattern do your numbers show? Try exploring more combinations after the lesson. Remember to subscribe if you enjoy learning this way. Optimizations and best practices. Use clear labels for axis names and titles. Always preview your data before plotting. If you have many points, lower dot size or use alpha for better visibility. Check for missing or strange values that may confuse your results. Running the cell now. Troubleshooting is normal. Here are a few common things to check. This code prints out useful reminders if a plot is not appearing. Always make sure you show plots by calling plt.show. Data must be numbers for most plots. A small typo can stop a plot from working. Try to run cells in order so all variables are ready. If things look blank, restarting and rerunning often helps. Running the cell now. Keep these tips in mind as you experiment with your plots. Extra tips. Try switching plot types for new insights. Use hue and style in Seaborn plots to show categories clearly. For huge datasets, sample smaller pieces to keep plots readable. Check Seaborn's documentation for even more options and examples. Running the cell now. Challenge: what could you explore next? 1. Try plotting passengers versus month for part of the data. 2. Make a Pairplot with more weather columns if available. 3. Gather your own data and make a relationship plot from scratch. Be creative and have fun discovering patterns. Running the cell now. Quick recap. You learned how to draw scatter plots to see connections. Add regression lines for trends. Use pairplots for broader views. Make cool plots with real data. You are ready to spot patterns in your own projects. Running the cell now. Thanks and next steps. Thank you for following along. Try out more datasets or share your plots online. If this helped you, consider subscribing and liking the video for more friendly Python tutorials. Running the cell now. What plot are you excited to try next? If you like this, subscribe for more fun lessons.